Good afternoon, everyone. On behalf of the Victorian team at the Institute of Architects, I'd like to offer a warm welcome to today's lean-in, Counting a Carbon, Managing Carbon During the Design Process. My name is Kirby Roper, and I'm from Kirby Architects, and I'm the co-chair of the Victorian AIA Sustainable Architecture Committee, as well as Secretary of the Association of Consulting Architects, Victorian and Tasmanian branch. And it's my honour to be your host and moderator for today's lean-in session. We're joining from across the country today, and we acknowledge with deep respect the traditional owners of this land. We acknowledge that it is a privilege to stand on country and walk in the footsteps of those before us. And we pay our respects to elders past, present, and emerging. The lean-in session is being recorded, so if you miss anything today or you have to leave early, it will be published on the Institute YouTube channel in the next couple of days. And we will also share the link with you on our upcoming email communications. This lean-in session enables you to ask questions of our panellists. So if you have any questions and comments, please use our Q&A box down below and add yours in. I'll go through these later in the session. Patrick Kelly is an architect at Breathe Architecture in Melbourne, specialising in sustainable design and carbon-conscious architecture. He has led the development of the firm's internal carbon measurement process and reporting, driving impactful change in how carbon is quantified and managed through the design and construction phases. In today's lean-in, Patrick will discuss how Breathe integrates carbon quantification and management into that design process. Welcome, Patrick.
Thank you. Just share my screen. Hopefully everyone can see this. Thank you. This is Counting Carbon, Managing Carbon During the Design Process. It's going to be a bit of a discussion at a reasonably high level about how we've thought about carbon here at Breathe and how we've tried to implement kind of a management process for how we kind of use carbon within our office. As always, we'd first like to acknowledge the traditional owners of the land, the Wurundjeri people of the Kulin Nation, the traditional custodians of the land on which we stand here in Melbourne. We pay our respect to their elders, past and present, and to all First Nations peoples of Australia. We acknowledge their continued and unceded connection to country and culture. Always was, always will be, Aboriginal land. So, carbon. I'm conscious that this might be a bit of a dry topic, so I'm going to try not to get too caught up in the weeds with it. No one needs to worry. There's going to be no spreadsheets. There's going to be no talk of specific minute things you can do to try and save carbon during the process. This is going to be a high-level discussion about what we've done here at Breathe and how we've tried to think about carbon. A little bit about me. As Kirby said, my name's Patrick Kelly. I'm an architect here at Breathe. And I kind of wanted to put this up to begin with as a little bit of a disclaimer. My role here at Breed is primarily one of an architect. Most of what I do day in, day out is architecture related, and it's on the side we kind of manage the carbon aspect of it. What that means is I'm by no means an expert in carbon. I have conversations with people that have a deep and technical knowledge of this subject, and it's kind of humbling to realize how much they know, and I'm not necessarily one of those people. But what I think I can bring to discussion is a conversation about how architects think, because I am one. I know the challenges we face and the kind of conversations we have in the office. And so what I think I can bring to this discussion is a holistic approach to carbon and kind of thinking at a really pragmatic first principles levels, what we as architects can do to manage it during the design process. So to start with the why, I mean, being an architect's already a pretty complex thing. There's a whole lot of standards we need to adhere to. There's the national construction codes. We're managing clients, we're managing contractors, we're managing other consultants. Sometimes we're even managing other architects. It's a maze of different things to kind of adhere to understand. It's kind of amazing anything gets built. What I didn't want this to be is carbon to be an add-on to that conversation. I didn't want it to be something that sits on the outside as an additional thing to worry about, an additional thing to keep you up at night. For us, we wanted to bring it in that was core to what we did here and how we thought about buildings as a whole. And so to briefly touch on the word carbon and kind of what it means to us, I feel like it's unfortunately a word that's kind of been taken
Sorry
over.
to jump in, Patrick. Apologies. I feel we cannot see the slides changing.
Can you, sorry about this. Can you see the slides changing now?
Yes, now it's
Yeah,
working. Sorry. Apologies.
no worries. I'm glad someone spoke up before I went too far. So to talk a little bit about carbon and what it means to us here, I mean, carbon for us is a word I fear that's been taken over a little bit by marketing professionals. There's so many different terminologies out there. Carbon neutral, carbon positive, carbon negative, conscious carbon, caring about carbon. There's all of this terminology. And I think sometimes the core idea gets a bit lost. For us, carbon's a very simple thing. Whenever we design and build buildings, energy goes into building those buildings and operating them. Associated with that energy, um, carbon is released. When carbon dioxide is obviously released into the atmosphere, it's clearly a greenhouse gas. When we release more carbon than our planet can absorb, this increases, and this traps radiation from the sun, which leads to global warming. For us, it's a really clear-cut thing. What our aspirations are is, as designers and as architects, to still produce quality outcome buildings, to still produce buildings that we're really proud of, but to try and lower the absolute carbon associated with those buildings. That's core to kind of what we do here, and that's what we're trying to achieve. So, all right. If you think in any one year, there's a huge amount of global carbon that we emit into the atmosphere as a collective of individuals. Of that 100% carbon, approximately 38%, so more than a third of that comes from building and building related activities. So this is you go home at night, you turn on the light, you turn on the conditioning. There's energy associated with all of that. To produce that energy, carbon needs to be emitted into the atmosphere. Or it could be someone on site on a construction site, pouring concrete or putting in steel or operating a crane. Again, all of those things, there's energy associated with that, and that leads to carbon in the atmosphere. Of that 37%, 20% of that, so more than a quarter of the total global carbon comes from building operations. So this is buildings that are complete. It's the energy that we pump in them just to keep the lights on, to keep the air conditioning running, to keep the hair dryers going and whatnot. Of that 27%, I'll say the 10 additional percent to take it up to 37 is embodied carbon. So this is a carbon that we invest right at the start of a project. So it's a carbon that goes into constructing the building. So think about the steel structure, think about the concrete that's in it, think about all the fixtures and finishes, think about the kind of energy the contractor's using on site. So there's a huge quantity of carbon globally that's taken up by buildings. And that's a really important thing to be aware of as an architect. When we think about any one particular building, it all starts with the client. So whether it's a small residential alteration or a bathroom refurb or a multi-million dollar, new university campus, at the start of that project is always the client that has a brief and an overarching project vision of what they want to achieve. Typically, they engage an architect, and an architect comes up with designs and options for them. They make specification choices about how they respond to that brief, and they come up with options for the client. Once everyone's happy, we flow down this decision-making kind of tree to other consultants, such as engineers, whether structural engineers, acoustic engineers, mechanical engineers, but they take the design that an architects usually come up with, and they come up with solutions for how to make the building stand up, how to manage the heating and cooling loads, how to manage various aspects of it. When that's all done and everyone's happy, it goes to a contractor. They obviously go out to site and they put, hammer to nail and actually construct the building, put it all together. And then once that's done, it goes to the end user. And they're the person who comes home at night and, turns on the lights, plugs in their laptop, turns on the air conditioning, whatnot. When we think about this process and we think about who uses the most carbon over the life cycle of the building, it's the end user down at the bottom. Like they by far, through using the building, account for the most carbon. Above them, you've got the contractor. They use a huge amount in actually putting the building together, gathering all of those materials. You've got engineers above them. So if you look at any reports, you'll often find that the most amount of carbon in any single building comes from the structure of the building. And then you've got architects and clients above them. When we think about the influence of this kind of flow of decision making and who has the most, it's primarily architects. So engineers, contractors, and end users are all responding to what an architect puts on a page. They're all coming up with solutions to things that we've come up with in our head, and we respond to the client. So when you think about that 37% of total global carbon that comes from buildings, and you think about the profession that has the most influence over that, it's really architects. And I think that can be a bit of a sobering and nervous thought, because when you look at it in the profession, I think collectively we don't have a huge understanding of kind of how carbon operates. So for us, that's why it was really important to kind of come up and think about how we were using carbon in our practice and how we were managing and trying to reduce it. So to start with, we didn't really know much about anything, so we had a bit of a common sense approach to carbon. This was stuff that we inherently thought at a simple level makes sense to us. And there's really two outcomes we wanted from it. We wanted to zero and really focus in on the operational carbon because that's where the biggest output was. What was the best way to kind of try and completely eliminate this? And then secondly, what was the best way to cut that embodied carbon? So the carbon we put into a building right at the start when it's being constructed, how could we minimize this as much as possible? So to start with the zero operational carbon, there's really kind of three key gestures we did. There was a whole lot of little things, but three key things made the biggest difference. The first thing was to electrify everything. This meant that we weren't necessarily using natural gas for heating or for kind of our induction hobs and all of that. By electrifying everything, it meant we could educate clients on renewable energy. So this takes a massive load if you can get 100% renewable energy being used during the life cycle of your building off the overall carbon output of it. And then finally, for a couple of buildings we did at the start, a couple of the Nightingale projects, we went through this kind of certification process where we got kind of the owner's corporation to commit to buying 100% renewable energy. Not every building we have necessarily goes through that. So a lot of our focus is on educating clients about how important it was from a carbon point of view to try and embed renewable energy within their project and to use that. We often found it's kind of the easiest and single biggest thing that makes a difference. When we talk about embodied carbon is much more difficult to cut out. So there's a couple of key things we thought about from a kind of first principles, what inherently made sense to us, not being necessarily experts in the field. The first was really on designing efficiently. That didn't mean that every home needed to be a tiny home, but it meant being really clear about how our spaces were being used, trying to account for every square meter that we were using. I mean, every time we design a project, we're trying to think about what's the most rational solution, what's the best way we can get the most outcome for the least amount of materials. Talking about materials, we also generally practice this kind of idea of reductionism. So this is being critical about the materials we're using and thinking about how we minimize them and be able to be articulate about what we are using and why we're using it. It's not necessarily coming into a project and plastering lots of materials everywhere just for the sake of it or just for the sake of how it looks, but it's trying to think about why we're putting in what we're putting, what the function of that material is, and how it's going to perform in the long term. And finally, there was kind of material selection. So we had a team here that's done a whole lot of research into different materials. Generally speaking, as an office, we tend to select quite a few materials, but we think really critically about what those materials are and why we're choosing them. The key thing we're always looking for in materials is that they're transparent. We know what's going into them and we know why we're choosing it. But we're also generally looking at kind of things with low VOCs that are healthy, that don't have any bad gases in them. We're looking at where they're coming from and we're looking at the longevity. And so then we came on to this question of measurement. So we were doing all of these things. We kind of, in our heads, it made sense to us why we were doing them, but what gets measured gets managed. So we kind of wanted to approach this thing and like, how do we measure and think about carbon and how do we use those measurements to inform the decisions that we're making? And so I think like a lot of the industry, we kind of really focused in on life cycle assessments. So for anyone out there that doesn't know what a life cycle assessment is, it basically looks at a building over the whole of its life and it breaks it down into key stages. So there's kind of the production stage, there's a construction stage, there's a use stage, and there's the end of life stage. And then below each stage, there's several sub-stages like the raw materials, the transport, the actual manufacturing, the maintenance, the repair, the replacement of materials. And so what a life cycle assessment tries to do is to quantify each one of these things. And in principle, what that means is you can look at all of the materials in your building as a whole and kind of determine what's working, what's not working, and how you might optioneer and kind of come up with different solutions for that. Anyone that's gotten a life cycle assessment might have an idea of the kind of reports you get, but they're usually really granular and detail orientated. We're talking lots of spreadsheet, lots of graphs, lots of comparisons, loads of data points. They're really important, and they're a really important critical point for us in a kind of the design phase, but they weren't necessarily the silver bullet that we were kind of hoping that they might have been. There's a couple of kind of reasons for this. Anyone that's gone through kind of a life cycle assessment on a building knows that they're quite cumbersome. In order to get the relevant data that you need to know a huge amount about the building. What this usually means is that you need to have a quantity surveyor involved, and they need to give you a detailed breakdown of all the materials that are going to show up to site. And in order for them to do that, they need to know exactly what the building's going to look like, exactly how the structure is going to work, how it's all going to be put together. Alternatively, if you don't have that, you need a really complex kind of detailed BIM model with all attributes to all of the individual materials so you can get detailed material takeoffs. It just takes ages to do. It's quite cumbersome. There's a lot of cross-referencing and a lot of checking. One of the challenges with it being cumbersome is that by the time you actually get the data you need from it, it's not really that actionable. So you need to know lots about the building, which means you need to basically design the building, which means you're kind of either about to start construction or you're kind of already starting construction. So that means by the time you actually get the feedback from that life cycle assessment, your project's already on site and you have minimal opportunity to kind of make meaningful changes. And so that was a real kind of issue we were having with LCAs, is that we were getting them and it was really interesting and we're reading through them, but it's like, we can't really action anything on them because the building's almost complete on site. So, it was a little bit frustrating. And the final point with them is that they were somewhat inaccessible. I mean, it takes, a huge amount of time to do them. They require experts to kind of go through and quantify different aspects of your model, which meant that they were all quite expensive. And that's fine on kind of the big kind of sustainable flagship projects and practices. But for us, a lot of the projects we do are small, they're residential, they're retrofits, they're kind of different things that fall outside the norm of kind of a typical flagship kind of sustainable project. And for us, it was really important that when we were thinking about carbon, that we were including these buildings as well. It wasn't that these were just forgotten about because we couldn't justify them. And so anyone that's read an LCA, the usual key number that they refer to is kind of this number. It's usually in the executive summary, the first couple of lines, but it'll say in this building, there's X amount of kgs of carbon per meter squared. So in this instance, it's 500. It could be 800, it could be 200, it could be 300, it varies. It usually tells you this, and then it goes, and this is 20% better than a bench line, or this is 30% better than a benchmark. We kind of found this number really useful in a sense because it allowed us to compare buildings of different size. So if we had, a small apartment building, maybe there's only 15 apartments in it. And if we had a large one of like 500, this kind of equalized them so we could look at them on a level playing field. But by using this meter squared number, we kind of discounted size. So it didn't matter how big our buildings were. It was more kind of how each individual square meter was performing. And that to us always made us felt a little bit uncomfortable, because for us the focus was on reducing the overall carbon, and part of that discussion was how do we kind of try and reduce the size and make buildings more efficient. And the way I kind of describe this to people is, if you imagine the typical Australian home, I mean, this usually isn't designed by an architect. It's a big box kind of Metricon home out in the suburbs somewhere. If you were thinking about this from a carbon per square meter mindset, the single biggest difference you can make to this home isn't by, specifying a carbon neutral brick. It isn't by kind of looking at alternative slab systems. It isn't by kind of putting double or triple glazing on the windows. The single biggest thing you can do if you want to bring the per square meter rate of carbon in this home down is to add a double garage on. And the reason that is because you're adding a whole lot of square meters to the house with relatively little material. So the whole house gets bigger, and that brings the carbon per square meter down. And obviously this didn't really sit right by us. We obviously understood that figure was a really important one on some level to understand, but it wasn't holistic enough for us. So we kind of had all of these things in mind, and we got to this point. It's like, well, what are we doing? What are we going to do to kind of manage this process for us, and what would be most beneficial? So we sat back and we kind of came up with three things that we needed to do, or three kind of qualities that we needed to have in our response. The first quality was that it needed to be actionable. There was no point to us doing an audit at the end of a process when the building's already on site and kind of going, great, how did we perform? We needed to be getting data kind of as we were developing the design. We needed to use that data to be able to make informed decisions about kind of the materials we're using, about the size of the building, about how we were thinking about sustainability as a whole. The second thing is that it needed to be simple. I mean, LCAs are great, but there's a lot of technical information in them. And a lot of software that you use to kind of create them tends to be a bit of a black box. You know, you put all of your data in, it spits a number out, and you don't really know how it's arrived necessarily at that number. And in order to do that, you need kind of technical experts to help you. For us, we just wanted something that was really simple, that we knew that everyone in the office would be able to pick up, to be able to use in their projects and be able to understand. That was kind of key for us to having something that would be able to be implemented. And the final and kind of most important point is we wanted something that was holistic. We didn't want to get to the end of a process and go, right, there's this much carbon per cubic meter in this project, and this is how it compares against a benchmark. That really wasn't the discussion point for us. For us, we wanted to understand the journey we went on in design in terms of how we thought about carbon at various different stages and the actions that we took to kind of try and reduce and manage that. And so we kind of came up with this graph. So on this bottom, on the x-axis through here, we have the different stages of design, kind of regardless of what they're called, you know, normally start at some sort of feasibility or concept, sketched, developed, detailed, and construction. This red line indicates the amount of information you need to be able to kind of quantify the amount of carbon in a building. And you can see here, right at the start, at the feasibility stage, we generally don't know much about the building other than kind of how big it's going to be. We don't know the materials, we don't know structurally how it's going to operate. As we go through the design, we start making decisions, we start kind of choosing, specifying materials, thinking about how these spaces are going to operate, thinking about how the structure is going to work. So as we go through design, our ability to calculate carbon goes up, and we eventually get to a point when we kind of know exactly what's in a building, and that's when a traditional LCA takes place. And as you can see for us, this was usually kind of in the construction phase. Again, the problem with this is the graph on the line on the graph that's green here, and that's our ability to influence carbon. And this kind of is almost inverse to the red line. So right at the start of a project, you know, it's really difficult to calculate the amount of carbon that that project is going to use, but the ability to change and influence carbon is really high. So when we're putting boxes on kind of pages and moving and pushing things around, that's when the opportunity is greatest to make savings, and that gradually diminishes over time. And you can kind of see this is talking to that problem I was saying earlier about the actionability of LCAs, is that we're getting these done right at the end because that's when they needed to be done to have the most accurate data. But we didn't have much of an ability to influence or make any meaningful change to specific buildings. So what we said to do is we needed to start right at the beginning at feasibility. We needed to come up with some way of benchmarking our buildings and thinking about carbon at this stage. And so the way we thought about it is we came up with this idea of an embodied carbon benchmark. So the numbers here are from an actual project. These little drawings on the top are not. But this is kind of how a typical feasibility study might look for us. So option one here, there's a whole lot of red little blocks. These are all 1-bedroom units. The yellow block might be a bit of communal space. The green block might be, you know, some green space. We've got a little bit of car parking in there. Option two, these blue blocks are townhouses. We've got a bit of a larger green space and we've got some car parking. And option three, you know, we've got a bit of a mixture. We've got some smaller apartments, some townhouses, and then the lime green ones in the bottom might be some commercial spaces. Normally for us, you know, feasibility mightn't be this drastically different, but, you know, sometimes we do get them where we're looking at a whole lot of different options on this. We don't know what these buildings are going to be. We don't know what they're going to be made at. So we have a relatively limited ability to calculate carbon. But what we do know is we do know roughly how big each one is and how much and what type each one is as well. So if we kind of think from an occupancy point of view, we can quite easily work out how many people, real rough as guts calculation, are going to be on each of these sites. So in this option one, we'll have 27 one-bedroom units. If you kind of think, yeah, it's probably about 1.5 people per one-bedroom unit. That equates to about 40 people on that site. Option two, it's a whole lot of 3-bedroom townhouses. That equates also to about 40. And option number three, it's a bit of a mixture. Again, that's coming in at 43. So from that, we can kind of work out how many people will be on these buildings. And then what we can also do is we can kind of work out just a basic business as usual case scenario for these. So we can go and we can find a benchmark for different types of buildings in Australia. We can find a benchmark for kind of landscape, for car parking, for commercial spaces, for residential spaces. Because we know what the rough area of each of these buildings is, we can then multiply that square meter benchmark by the square meters of our buildings and come up with a kind of a total figure for the amount of carbon as a just basic business as usual case for each of these options. What that means is we can then look at those two figures and come up with a rough kind of amount of tons of carbon embodied carbon that goes into each of these per occupant. So you can kind of see here, option one, it's about 34 tons. Option two, it's nearly 36. And option three, it's nearly 33. These don't seem like massive differences. There's about a 10% difference between the highest and the lowest here. But that single choice is going to have more of an impact. Oh, that single choice of about 10% will be greater than kind of any choices we could make downstream when it comes to kind of material selection and different things. So for us, it was really just at that early stage, trying to kind of put some figures together to understand how these sites were being used on a kind of per occupant level and how much carbon was associated with each of these. For us, it's never about kind of saying we must always go for the lowest option, but it's about understanding how the actions we're taking at this early stage are influencing carbon. And of course, feasibility studies and any part of design is always quite flexible. And what this becomes really useful is, say, for example, the design slightly changes. So maybe in option one, we add a couple more units on. In option two, maybe we take a couple off and have a communal space. And in option three, maybe we change the makeup. We can see how the carbon figures are changing as we're making these adjustments. And so what all of this was for our internal team to build up an intuition of like how the actions we were making early on were impacting the overall kind of carbon at this early stage. So we're kind of doing that as like, this is what we're doing. It's a really rough kind of line in the sand of what we think we can kind of achieve in these buildings. It's a benchmark that we set in feasibility stage. As we go through the design and we start making decisions on the materials and kind of the structure and the layouts and different things, we can start kind of being able to get more kind of accurate data on the amount of carbon that we're thinking of using. So we kind of coined this idea of a carbon snapshot. And the idea was that we would do this at several points throughout the project. And this wasn't about necessarily kind of getting an absolute accurate kind of precise figure of exactly what the carbon was, but it's more of a moment in time based on what our kind of model's looking like. If we did a whole lot of rough takeoffs and kind of rough calculations, how much carbon do we think we're using and how does that compare against the benchmark? So this is the kind of little report we produce. All of this occurs completely within our modeling software. So we don't need to export out anything and then re-import it into InDesign and kind of do a whole lot of graphs. This all completely happens within kind of our drawing software. And the reason we kind of push for it to be that way is so that people would be able to use it and it would all be there in front of them and it was as simple as possible. So we normally start this process at about the town planning stage or any stage really when we have a rough idea of what the building's going to look like. So at that stage, we might know, for example, that cladding's primarily brick and we've got this many windows and we'll have a concrete slab and a profiled metal roof. We might know those rough things, but we might not know the specific details. What we do is we kind of run a takeoff and then we can use that takeoff of those materials and we can multiply it by a whole lot of industry benchmarks to get a rough idea on what we think the carbon associated with each of those products is. And so what that means is that when we look against that initial benchmark, we can kind of see how we're tracking. We can go, are we way above what we thought we were going to have? Or are we way below? What's working for us? What isn't working? What's also really useful about this is it can give us a whole picture of the materials in a project. So we can kind of go, we know that a lot in this instance of this project was brick. So we know that about I think it was 22 or 23% of the total carbon associated with this particular project was in the brick cladding. And that gave us a direction to go, right, when we're thinking about specifying brick, we want to look for kind of low carbon options. We want to look for alternatives. We want to spend our time and energy looking at that because we know it's going to be the biggest win. So again, what we kind of do at this stage when we don't know specifically what the material is we use kind of an industry benchmark for those materials. So you can go online and you can find kind of carbon coefficients for specific materials. So in this instance, if we were looking at brick, we can kind of know what an average brick in Australia is. And we put that together and then we get a breakdown of the building as a whole. And we know where those areas and those sensitivities are. What that means is that as we go through the design process and people begin to specify brick, we can then, get in touch with the manufacturer and they can usually provide us with documentation on the actual carbon they use. And then we can use that as a comparison as to what we had initially estimated it as. And so that gives us a real direction in terms of at this early stage, we know what the materials are that are likely to produce the most carbon. So they're the ones that we focus our energy on. We try and look for good alternatives and good substitutions and good choices in those. And then we can directly see the percentage difference that we're getting. So say, for instance, brick, might be 100 kgs of carbon per meter squared of brick used. We might reach out to a manufacturer and we might be able to kind of figure out from them that their particular brick only uses 50. So for us, that would be a great outcome because we've reduced that by half. And what's important with this is that we're kind of continuously doing it through the design process. It's not something that we do a one and done at one stage and say this is a pass fail, but rather it's kind of something that we can kind of build on and develop. And we get a real picture for how our decisions and how we're thinking about the buildings are influencing the overall carbon within them. Right. And so briefly to talk on some observations, I mean, I wanted to call this conclusions, but conclusion sounds quite final and quite kind of definitive. For us, it's been a real journey. And so we kind of talked about observations. Here's things we've noticed. The first is really that buildings and carbon are pretty nuanced. I mean, it's a really complex conversation to have. I would love if there was a simple figure that we could point to and kind of say, this is the answer to everything, but it's a really nuanced conversation. We often go to presentations and, someone comes on stage and they start talking about their flagship building and they go, and it's, 20% better than a relevant benchmark. And we're always there kind of going, what benchmark are you using? How are you kind of deciding that it's 20% better? For us, the conversation is more fulfilling when it's kind of taken holistically and we're talking about how we've gone through the design process, how we've thought about how we're setting out the building, how we're kind of arranging things on site, and then how we're specifying building materials and things like that, that was a much more rich and rewarding conversation to have when it came to carbon. The second, for us, it was always more of a conversation starter. It was never a black and white thing such as a pass fail. We never kind of stopped and said, oh, this building looks like it's really high in carbon, we have to stop it. But it's more of a conversation starter of like, how do we approach and think about carbon? And we use this data to kind of give us direction in those conversations. So it's going, these are the sensitive points. These are the materials that are producing quite highly. What can we do to try and minimize them? How can we think about this? And they're always the most rich and rewarding conversations that you can have. And then finally, for us, like carbon is only part of the broader sustainability conversation. There's a real tendency when you present numbers and figures and graphs and kind of, percentages to people that they kind of gravitate towards the one that looks best. And that's a real challenge in kind of some of the communication. For us, we always say that carbon's not the only thing that we look at, but it's part of a whole kind of broader vision. So we might start with carbon more generally, but we're also looking at things like circularity as well as building health. And so depending on specific products or depending on specific projects, we're kind of balancing these three things in tandem. So it's never about going, we must select the absolute lowest carbon option, but it's about thinking about circularity and how a building can be taken apart and how bits of it can be reused and kind of the broader sense of that. And it's also about a building health and kind of the materials that are in a building, because there's lots of low carbon choices out there that have like high VOCs and kind of really nasty things in them. And so for us, it's really important to kind of balance health against these two other things and kind of come up with a more holistic approach to thinking about sustainability, rather than focusing on one set of numbers or one kind of dimension. I kind of came up with those observations and I thought they're not really very actionable for many people. So then I kind of thought I need to come up with some actionable observations and actual things we've seen. So if there's kind of one slide or one thing you take away, it's probably these final thoughts. The first is really like the biggest thing that affects building is size in terms of the overall carbon. So size really does matter, even though very often in the industry, we kind of tend to revert to square meter rates because that's easier to understand. So for anyone starting out, I'd say the best place to focus on is think about how you're making buildings more efficient. Think about kind of the materials that are in them, thinking about that overall picture of it. The second thing is big ticket items. I mean, you don't necessarily need to do a whole LCA to understand where your carbon's going to be. On 95% of all buildings, it's usually going to be in things like structure, such as steel and concrete and kind of reinforcing. So really think about how you're implementing and kind of making those efficient in buildings. Are your grids lining up so you don't have lots of transverse beams that are kind of, having complex structural solutions? It's thinking about how you can make the structural engineer's life simpler and kind of how you kind of reduce structure and then how you can kind of look at alternatives to that. And then finally, kind of the biggest single one thing we kind of recommend and we advocate anyone do is kind of to look at 100% renewable energy. That takes so much of the pressure off of that kind of operational aspect of carbon. It's often the single biggest thing you can do. So there's a huge amount of work we kind of advocate and try and educate our clients about why that was so important. And yeah, so I think those are like the three biggest things you can do. I'm not sure how I'm doing on time. Hopefully, I've got time for questions and stuff. And I've not bored anyone too silly.
Patrick, thank you so much. I've got a whole series of questions, and we do have some questions in the Q&A. I think my big takeaways from this so far is that it is not considering what you said. You're not trying to just put into a building pick all the materials that have the lowest carbon option, and there you go, voila. It is that whole process, and very much educating everyone along the way.
100%.
So I'm going to ask my question first, and then I'll get on to some in the chat. One thing that comes across, you've obviously, and we talked before, you've had to educate everyone within your work environment about how did you educate them on their benchmarks, that they can make a lot of those figures, which we find very relatable to them and relatable to a building. I loved your little slides of each of the size of the building to understand it. So how did they take that, and how did you make that relatable to everyone else in the office?
I think it was about kind of having a clear and cohesive message. I think often with carbon, you can kind of quickly get your head in the sand around the technical details. And so for us, like those slides that look at those kind of different feasibility studies, that's a really easy measurement to do. It's not rocket science. You go out, you find some benchmark for what typical buildings are in Australia, and you multiply those by the amount of square meters. And that's kind of quite an easy thing for people to understand and comprehend. And it's kind of going, look, let's not worry about all of the detail about material selections, about structure. All of that will come in time. But let's focus on making the buildings efficient now, because that's going to have the biggest impact at this stage. And then it's really, as we go through the design, we kind of start with like the overall set out of what the materials are and kind of what that is doing to the carbon. And kind of that then gives direction, because people can kind of see through some of the graphs and kind of some of the numbers that come out. Okay, of those overall figures, the biggest contributors are X, Y, and Z. So I should focus my time on trying to figure out those things, because that's going to have the most benefit. And for us, again, it's a conversation starter. It's never kind of, you must do this, but it's like, all right, let's focus on these things. What are our options around them? How do we consider it? And it is an evolving process.
Yeah. We might follow up, and I know there's probably been a couple of questions about where you find those benchmarking. So we might follow up with that and actually provide that back with some of our communication.
Yeah, absolutely.
I'm going to jump to Michael. You've got your hand up. Do you want to ask a question? Are you able to turn on? Okay. we might come back. I'm not great on the technical side of this, so I might just ask Tom's question, which was, what software do you use? Because you mentioned that you had the reports that were produced naturally through the design software.
Yeah, so we in the office use ArchiCAD to do all of our modeling, and then we have a plugin to that called Design LCA, and it's a really simple piece of software, but it basically goes around and it kind of quantifies the amount of material you have in any given project, and then you can put in your own relevant benchmarks against that. It's a free piece of software. It comes from a couple of Danish architects, which is really cool. And so, yeah, there's a low barrier for entry, which is great.
Did you, and I'll ask this because I hope it extends it and that helps you, Tom, and I hope you use ArchiCAD and that's easy. Did you find that you jumped straight into that first, or did you find that you had to do the broad research around understanding how you were going to apply your carbon accounting within the office?
I would love to say that we started from the outwards and worked our way in, and that we started from the broad and worked our way to the detail. In reality, that's not how it happened. We kind of got design LCA, we started playing around, seeing what different things came up with, and then kind of from there, kind of worked from the detail outwards to kind of that overarching structure. It's been a journey for us. It's not necessarily a perfect solution. It's evolving. I'm sure in time it'll change, but we kind of figure having a bit of a direction is the most important thing.
Great. Well, I think I can think of another lean-in just on how to actually understand the software at a future stage. One of the other questions was, first, thanking you for the lecture. It's obviously been really fascinating. What is the efficiency of electrification and all renewable energy when it comes to cost of use ratio? Is that getting too specific? But I think that was around when you were talking about just going complete electrification with construction.
It's a fairly specific and nuanced question. I probably don't have the answer off the top of my head in terms of the exact cost. What I think more broadly we're trying to say is that from an operational point of view, for someone living in a building, lots of carbon associated with that. The biggest single thing they can do is kind of go to 100% green electric, renewable sources, and vote with their feet. I mean, in my personal life, I've done that in our apartment and I've not noticed any different in the electricity bills. So, you know, we kind of push people to kind of vote with their feet, and that's really important. So we kind of say there's not really, in our minds, like massive differences, but it makes a huge difference overall.
Yep. No, that's fantastic. We don't have any other written questions here. Has anyone got, oh, Matthew, you've got your hand raised. I'm not quite sure how to get to you, so perhaps you will switch yourself on and ask a question. We've got two people with their hands raised. Matthew and Matthew, who both stuck your hands up, can you possibly shoot me a question and I can ask? So see how quickly you can type. And in the process, perhaps I can loop back to where are we here? There we go. Thank you very much. Matthew, as I'll read it for you, I'll see if I can put your voice on. Great conversation and really good overview of what is a very complex process. A couple of questions, and happy to follow up beyond this chat. Are all calculations manual? Are software being employed to streamline these calculations, such as Autodesk Forma or Tally? I think you've answered that one already, but perhaps I'll let you respond to that one, Patrick.
Yeah, that was a huge part of trying to make it as simple as possible, was to kind of automate as much of it as we could. I know in the past we had done things where it's like you have to export your model into an Excel file and then you have to cross-reference everything, and we really wanted to avoid that. So we've kind of managed to, excuse me, kind of make almost all of it completely automatic. There's a couple of key points where you do need to get the calculator out and do one or two calculations, but it's really not that onerous. We would say the bigger part and kind of the bigger challenge we're having is just ensuring that our models are modeled accurately, because obviously when the kind of programs go and they read the data, they're kind of reading it exactly as it's been modeled. So if something's kind of not quite right, then that can throw things a little bit. So for us, it does require a bit of common sense when we get the figures that we need to go through them and kind of go, hold on, does this make sense here? And sometimes we find that they're a little bit off and have to adjust things, but I think we're getting better at it, and it's really not that onerous. It's just really starting is more of the challenge.
That's fantastic. Thank you. One of the questions which, is where do you find the carbon benchmarks?
Yeah, so there's two that we've kind of come to. There's a lot out there, and it's really challenging comparing benchmarks against benchmarks because sometimes they can be measuring quite different things. And so it's really frustrating when you do that. But there's two sources that we've found that have been really good. Firstly, Slattery's the quantity surveyor producer report every year that's kind of looks at all of their projects that they do and gives a weighted average for different sectors. It's quite a short report, but it's really well worth a read. The second, which is for more specific materials, we use it. The neighbors have released a new technical workbook about embodied carbon, and that's a really fascinating document. Again, it can be a little bit technical in parts, but the key thing about that is that it's looking at Australia-specific materials and coming up with weighted averages. And that's really key for us, particularly in those early stages, because we can just apply the weighted averages to kind of see roughly how we're doing. And as we get more granular, then we can look at material-specific things. When we're looking at material-specific things, we're usually looking for an EPD because that's the gold standard environmental product declaration. And that usually has carbon values within them. Again, they can be a little bit tricky because sometimes they come from different countries and you kind of need to account for that. But by and large, don't get caught too much in that detail. Just look at the overarching numbers and kind of the big things you can do to make a difference.
Wonderful, wonderful. Probably this is an interesting. What is your sales pitch to developers to convince them on electrification? That would be on clients, really.
It's an interesting question. The whole electrification thing kind of predates some of my work on Breathe. But what I can talk to a little bit is kind of how we talk about sustainability more broadly to clients. And for us, it's kind of core to what we do. Often we've found that people assume that with sustainable buildings and kind of there's a cost associated with that. Because if you think about it, someone approaching a building goes, well, for this to be sustainable, I need to put a whole lot of eco products in it. If a product's got the word eco in it, there's usually a premium on it. Ipso facto, sustainability building costs more. But what we really focus on, depending on different clients, is kind of that core message right at the start that it was about being really efficient with space, is about being really selective about materials, and it was about thinking really thoroughly through. And we often find that they kind of align really well with what developers want because there's a cost to building. So the more efficient we can be and the kind of more we can reduce and take out of our buildings, that's a win-win on both accounts.
No, it's wonderful. Did you trial any other software before landing on Design LCA?
I think, again, this predates me a little bit, but I think over time we had trialed numerous softwares. So we can't comment probably on any one particular software because it probably evolved in that time. But look, everything can be a little bit cumbersome when you first start. So it's really about getting a streamlined process in. What I would say is it's not too particularly important what specific software people are using, but more that they are using it and they're getting data out of it that they feel like they can use.
Yeah, lovely. And another one, do architects have to understand the life expectancy of the structure and materials, composition of the materials such that it can be recycled? And usually, how is this practically informed during I think that's supposed to be first project stages. Do you want me to break that down again? Because that was a lot. How do architects understand the life? Do architects have to understand the life expectancy of their structure and materials and those composition of those materials such that it can be recycled?
Absolutely. And I think that comes a little bit to one of those last slides I showed. So carbon's one part of the conversation and understanding that. but you also need to weight that against something that we call circularity. So that's looking at a product kind of throughout each stage in terms of how it can be recycled and reused. And so we often find it's quite a project specific thing. So for example, if we were doing, a large apartment building, the intent is for that to stay there a very long time. So we'd invest in kind of materials that would kind of last that period. If you're doing something like an interior fit out, often there's more change involved. So we kind of spend a lot of time thinking about, okay, how does someone like disassemble this and how can all of these individual components be reused? And I think that's why it's important not to just get stuck on carbon and become obsessed with that and kind of trying to optimize that completely, but it's about trying to balance those other things.
Yeah, right. And a quick one, how do you address operational carbon?
I think that goes back to, so operational carbon accounts for a huge proportion of the building. I think that really goes back to educating people about 100% renewables. Obviously, there's design things we can do to kind of minimize the amount of heating and cooling loads on a building. They're all really important. But we've always felt like 100% renewables is the big step that's kind of relatively easy and everyone should be pushing to do. And that's what we advocate for.
Yeah, it's the one you can probably influence the most, isn't it?
Yeah, absolutely.
Everything else, it's a bit harder to do. I think we've covered this before. You've said what sources do you use for embodied carbon benchmarks? Yeah, the different typologies. You've covered that. How do you discourage value engineering? We often see our climate positive initiatives deleted or overlooked in the value engineering process.
It's a really good question. I think one of the biggest challenges is like you can come up with all the numbers and all of the figures you want, but what's more important is kind of how you communicate with clients and how we talk about this more broadly. Like that has a bigger influence than specific numbers.
Yeah.
To talk to maybe a project I was involved in a couple of months ago, we had a really great building. We were happy with it. There's lots of sustainable initiatives in it, and it went through a value engineering phase. And kind of the clients come back with their tail between their legs, going, "Look, we need to pull some of these things out." And so we kind of represented the design to them. And the very first slide I showed them was very similar to that slide about material reduction, about being efficient, and about material selection. But instead of talking about it through a sustainability bent, I said, look, every square meter of this building is costing you money. So let's try and make it as efficient as possible. Let's try and reduce the amount of materials we're using. So let's not unnecessarily just put lots of stuff in there. And where we are using materials, you still want a really great outcome of a building. So let's be really selective about those materials that we're using. And let's think about, what looks and feels and performs really well. And so I kind of took them through that process. And then at the end, I kind of said, oh, and by the way, they're all still really good, sustainable things we're doing. So we're not necessarily losing that initial brief. It's tricky because I think people's perception is that there is a price tag on sustainability. And sometimes it's just about taking people on that journey about how you're thinking about a project and how you're adapting to their specific needs.
Yeah, quite often, yeah. And you don't always win, but sometimes it's giving that option, isn't it? That there is a bit of a cost in making the right decision, but long term it will be a better decision.
And sometimes, honestly, it's about saying, look, it might be a bit more expensive to put this material in right now, but from a maintenance point of view, it's going to be a lot easier. So it's going to save you money in the long term. It's just knowing about the levers to pull with specific clients.
Yeah, yeah, exactly. It's understanding your client, isn't it? Georgia said, firstly, great presentation. She has a question on the carbon snapshots. Is this done for each project across the whole office? And how do you make this user-friendly for everyone in the office?
Really good question. We're trying to implement it so it is across every project, and we're trying to kind of backdate it because obviously we have lots of projects in different stage. So trying to get a whole picture kind of as our office as a whole, where we stand. We've really focused, and I suppose we've really pushed for it to be as user friendly. So everything exists within the drawing software. So no one's having to export anything. All of the templates have been set up. All of the information is assigned to the materials. So for our project team, what they need to do is they need to kind of refresh a couple of views and they need to check through their model to make sure things are correct. And then they need to have a bit of a sense check on some of the figures. And, our team kind of helps them with that if they need it. But we've kind of pushed for that to be as simple to use as possible. And again, it's not getting caught up in some of the detail with it. Like, we know that the figures that come out of it aren't perfect. They're nowhere near as accurate as like a fully fledged detailed LCA would be, but that's okay. We're still kind of having that direction to be pushed in, which is a real important thing.
Yeah, no, that's wonderful. How much time and effort did it take? And was there someone outside that you could lean on to help you put all of that data, I'm assuming, into the design LCA or any other software that someone has there to be able to get those reports out?
I mean, the biggest time and effort is really in a trial and error phase. I mean, it looks simple and it looks nice and easy here, but there was a huge amount that we went back and forth on and trying different things, and oh, this isn't working, and X, Y, and Z. So there was a bit of time. It wasn't crazy. I mean, like I said at the start, my primary role is an architect. As much as I'd love to spend every day doing this, there's still invoicing to do and different things. So we have to kind of fit it in around that. But it was important to us, so we did kind of push and make that effort.
Yeah.
And if anyone does have like questions, just flick me an email and I can kind of point them in the right direction. I'm more than happy to donate a bit of my time if someone is struggling or they're trying to get something off the ground. Absolutely more than happy to do that.
Thank you. I mean, I know that that's helpful. I know we run ArchiCAD, and I know we've looked at it, but we've wondered how onerous it would be to actually start. So you've given me the inspiration today to really launch on that and the understanding. So there are no more questions there. I'm sure if people do have questions, they can send them through over time.
Absolutely.
Patrick, I want to thank you so much for really just breaking it down so that it is doable. Because I think a lot of architects struggle under what is going to be coming at us for having the level of understanding that we're going to have and the level of reporting and auditing we're going to have to do. But this, if you've got it ingrained into the design and the thought process from the beginning, it will make it much easier than just doing an LCA at the end and getting a shock and having to go back to the beginning of that design process. I loved your whole thought process around that. Thank you. Before I say thank you, I wanted to, thank everyone else for joining us. I know we have, around 55 people on the lean-in today. And just a reminder that the lean-ins are recorded so that you can view them later, so that you can share them later, so that you can share them with the rest of your office and with anyone else that that may find them interesting. You can receive notifications when new lean-ins are available to be viewed by subscribing to the Australian Institute of Architects YouTube channel. And I will put that up in the Q&A in a minute, but it's YouTube at AUS Architects. And if you do that, if not, you can just Google the topic and it pops up anyway. Patrick, thank you so much for spending this time with us. I've found it's been really valuable and I know everyone else has. So thank you.
Thank you.